Thank you all for being here today. So today we're going to talk through all sorts of stuff about pivot tables. So I typically use pivot tables with my team for a few reasons. I think if you're on my team and we've talked about data analysis, you've probably heard me say this, but if you're in an area where there's not a ton of research being done, there's kind of like this inverse relationship between the amount of research done in your area and kind of the complexity of the analysis that you need to be doing. So if you're doing something, in childhood leukemia where there's a ton of repeated, studies and you're getting to the point where you're making like advanced statistical measurements, then, you're going to be not using Excel. But in situations like familial hypercholesterolemia research in children where less than 1% of the population is identified, you're going to start out working with descriptive statistics. And I think that Excel is an excellent tool for doing that. And secondly, I don't think that I have ever spoken with a clinician who enjoys looking at like SPSS output. And so most of the clinicians we work with are just more familiar and like Excel friendly. So I think it's a pretty good place to start. So for this presentation, I'm going to walk through like creating a pivot table and then some tips and tricks to kind of help out with making it a little more useful for you. So first, what we're going to do is walk through this Excel file. One more note is I didn't create a presentation for this because I think one of the benefits to pivot tables is that they're dynamic. And so watching it be created in real time is more interesting than having screenshots of everything being done. Secondly, I was supposed to teach a biostatistics course at TCU this week, but I couldn't make it because of a training I'm working on, and I recorded it and just did not enjoy that at all. So I figured we would do this live together. So we'll get started by kind of orienting ourselves with the database and the data within it. So what I did is I created a dummy data set of some cholesterol screening data. And so we have a fake ID here for the patient. We have a randomized date that goes back to 2017. We have sex, being male or female. We have different races. We have insurance package type, whether they're on an HMO, Medicaid, or some other policy. We have a department name. This is going to encode for which neighborhood clinic a patient would have been screened at. And then we have a result category, and this is going to give us our LDL cholesterol value. I'm going to scroll down just so I can show you. So this column will have a value if the patient had screening done. If they didn't, they were not screened. And so that's kind of one of our like qualifiers for this data set. This last column is going to be a result category. So this is something I created just using conditional formatting. I'll show you why I do it this way instead of working with pivot table grouping. We're not really going to use it that much other than just to like show an example. But that's a created column. And then I also have a second spreadsheet that includes genetic testing for patients who would have had this done if they had an LDL cholesterol value returned as a part of screening over 160 milligrams per deciliter, which in children is typically going to be indicative of a genetic condition causing hypercholesterolemia. So now that we've oriented ourselves with the spreadsheet, the next step is going to be to create the pivot table. So what we'll do up here at the top is go over to Insert on our top ribbon. We'll go to Pivot Table. We'll select our range. I've already done this because when you have more than one spreadsheet, you have to go through and like select all the data that you're interested in including. So what you do is hit OK. It'll create it on a new worksheet ply. And this is the output that you get over here. So what we see is this is going to be where the pivot table is kind of reported out to you. And then the pivot table fields over here are going to be kind of where you create everything. So a couple notes are that you can actually adjust this view to make it more like friendly for you if you'd like to. I typically leave it in this format. The second thing is you can actually you can sort your data fields into two orders. So you can do A to Z, so you can look at them this way. If you have a longer data set, this is going to be, or a wider data set, I guess, this is going to be helpful if you don't know where your data lies. And then you can leave it in the data source order, which is going to be ordered in relation to how it was in the spreadsheet. So next, we're going to create our first pivot table. We're going to do this and also discuss this idea of grouping that we talked about right at the beginning. So first, we're going to create a table that looks at our LDL cholesterol values. I'll show you why we're doing this in just a second. This one is kind of crazy. And then we're going to look at a count of our ID over here. So it's going to default to a sum. Whenever you're looking at your values, you can go over here, select value settings, change it from a sum to a count, and that will tell you how many people fell within each one of these kind of ranges. What we're going to do now is actually group this data. So as I mentioned on this screening data set, we have this result category. But if this isn't something that you create, you can actually do it within the file itself. So you can select the row label, come over here, go to group. And in this situation, we're going to create a group of LDL cholesterol values that start at 0 and end at 190, because the typical clinical diagnosis in a person with FH is going to be an LDL cholesterol of 190 or above. And we're going to group that by 190. So it creates two groups for us. So we're going to see our blank group is going to be the number of patients that did not have screening completed, but were eligible. This is going to be our group that falls within that 0 to 190, or what we're going to consider right now as normal LDL cholesterol, although that is completely wrong. It's not normal. We're just looking at this for a specific purpose. And here we're going to have a group of 3 patients that had their LDL cholesterol over 190 reported back to us. And so the next step is going to be actually realizing that we can drill down on our data within a pivot table. So as we saw on this data set, like, yeah, we can sort and roll through here and find the data that we're looking for. However, we have over 5,000 rows here. It's kind of, or 4,000 rows. It's kind of a hassle to go through and find specifics there. So if we see this and we think, okay, we need to look at these, you can double click on the ID. It's going to create a new sheet here. And what we see is we have a list of IDs that show their results, all the data that would pull from that screening data set. And what we notice here is we have this 1702 ID has a result that's 701. And so this is completely possible. So if you have a child with homozygous familial hypercholesterolemia, let's say we go back in the chart and we double check this and we see that that's not correct, that should be 70. So what we can do is, I'm going to delete it because we'll come back to it later. We can go into our screening data set, find that 1702 ID down here, find that, correct that value, 70, and then come back to our pivot table, and we can refresh that field. So we go to Pivot Table Tools, Analyze, Refresh, and now that data is corrected in our pivot table. So that's an example of how to drill down on your data directly from your pivot table. The next thing we're going to do is actually go back and create a new pivot table to look at some additional techniques that we can do. So we're going to ungroup this just in case we come back. I'm going to remove the rows, remove the columns. We're going to create a new pivot table here. So now we're going to want to look at department name. So these are going to be our neighborhood clinics that conduct screening. And we're going to look at a count of the results they return. So here we see we're in count, we're not in a sum. So what we see is we have 166 completed screenings from Arlington all the way through 193 with the Richland Hills Neighborhood Clinic. However, if you're working with a physician who doesn't want these raw numbers, you don't want these raw numbers, there are ways you can address this. So instead of looking at a count, we can add in a second column of our result data set, and we can right click on this and go to summarize values as a % of the grand total. Now what we see is instead of our raw values, we're getting a count directly in the pivot table as opposed to having to go through Excel and do the the conditions or the percentage calculations. So that's just a fairly simple way to get there. Another way to kind of help with data visualization on this is going to be the use of data bars. What we can do is actually go through here and select our percentages, and we're going to go over to the home ribbon. We are going to go to conditional formatting and add on data bars. So we can see instead of, just the number, we're getting some sort of visualization there. And then say on top of that, okay, we want to start looking at performance relative to the other groups. So we'll go back into conditional formatting, data bars, more rules. We look at our new formatting rules. We can come down here to format style, and we can go to a 3-color scale. We can say our lowest values are going to be red, our 50th percentile will be yellow, our highest values will be green. We can see here, okay, our lowest performers, in this case, again, this is not real data, are going to be Arlington, our mid performer is Miller, and then our high performers are going to be Renaissance and McCart. You can also, you can like sort this if you want to directly in the pivot table. So you can sort through these, not because these are already formatted, but we can do it over here. The next thing we're going to do is actually see how to visualize this data through a pivot chart instead of a pivot table. So what we'll do is we'll go over here to pivot tables, analyze, pivot chart, and this is going to give us the options that we can select. We're just going to do the first one, because it's simple. And we can start looking at this data in this way instead of looking at it as these raw numbers. This actually does have a second count on here. It's just not showing up. But whenever you do this, it's going to pull up any of your results that you're looking at for your pivot table. Something else we can do is adding on a timeline to our pivot table. So if we are doing something like looking at screening and we want to know, okay, how often are these clinics, reaching certain screening thresholds? How often are they hitting, 100 patients a month or 100 patients a quarter? We can add in a timeline that dynamically adjusts all this data kind of on the fly. What you need is to have a field that is going to be a date. We go back to our fields over here. We see that our second column, all the way back up, encounter date is set as a date field. So what we'll do is we'll go in here, right click on the date field, and we're going to come down here to add at the timeline. This is going to pop up as an encounter date timeline that we can expand out. And what we see, it actually comes out pretty late, but what we can see is that we can adjust this and our values adjust as we move back and forth. We can also, as I mentioned, we're looking at months. We can change this to quarters, and we can adjust, if we're looking at Q3 of 2017 and Q4, there's all sorts of possibilities with this. So that's an example of how to use a timeline with both a pivot table and a pivot chart. The next thing we can do is add on something called a slicer. So I'm just going to leave all of this on here so you can see that it's all kind of dynamic and works at the same time. But let's say we want to start looking at how these clinics are performing in relation to race. Like what do their screening rates look like for African Americans versus white, things like that. So we can go to our race category and add it as a slicer by right-clicking and going to add as a slicer. So here, let's say we want to look at only African Americans. That's going to adjust our data here. We want to look at only Asian. Or we can come in here and we can select multiple by using this multi-select option up here, and then going through and adjusting again, kind of on the fly. So it's just a really good way to kind of, when I know with Dr. Wilson, with Dr. Thornton, people who have these descriptive questions and always are thinking about the next question, this is a good way to both access the data quickly, visualize the data, and get it to them in a way that's kind of understandable and less confusing than like an SPSS output. So next, let's say we're going to remove the race filter here so we can get back to all of our data. In this situation, we want to look at like the top 3 performing clinics who have, the most number of screenings conducted. So here we would add what's called a top filter. So we would select our rows, right click, go down to filter, And let's look at top 10. So that's just the label. You can adjust this as needed to, let's say, top 3. We're going to do this number of items and by the count of result, which is what our first column is here. So now that filters out the data that we're looking at. And I don't know that I prepared this, but if we adjust here and there's a change in these top 3, this can actually adjust kind of on the fly with that too. So just keep that in mind. But this is a way to create additional filters if you're just looking for top, bottom, mid performers, things like that. Okay. The next thing is going to be the creation of a report filter. And so this is actually fairly simple. We can see down here the filter is an option on our pivot table creation. However, there's a couple of tricks that I think are kind of interesting to use, especially in situations like this where we're looking at kind of multiple potential data sets being each of the neighborhood clinics. So we're actually going to adjust our pivot table, remove everything, and restart. So let's say here we want to look at a breakdown of race again, and we're going to look at average LDL cholesterol value. So result is going to be our LDL cholesterol label. Right now we're set in count, but we can adjust that by coming down here into the value field settings, adjust over average. Again, you can look at all of this. So sum, count, min, max, product, count numbers, standard deviation, variance, all sorts of stuff. Here, let's adjust this because we never use decimals in LDL cholesterol values. So we're going to select our data, click here, right click, go to number format, down to numbers, remove the decimal places. Now we have more palatable numbers to look at. And now we're going to create our filter on this by department name. So here, this is pretty standard. We can go through and we can select, okay, let's look at just the Arlington Clinic. You can again do multi-select and add as many as you'd like to. Let's go back to all. The point here is actually you can do something a little bit different, which say we want to look at each of these separately, but don't want to have to click through and break out each of these. So what we'll do is we'll come up here, go to pivot table, analyze, over here on our pivot table name, which we can name if we want to, come down to options. We're going to show our report filter pages, and we're going to select department names since that's the only thing we're kind of filtering by right now. We click OK, and now we look down at the bottom. We have additional pivot tables created for each of the neighborhood clinics here. And so that can be useful when you want to start breaking down into these kind of larger categories. All right, so the next thing we're going to talk about is something called a power pivot table. And we do that by combining multiple data sheets. And so typically what we look at is, this is our one sheet, just our screening data. But say we want to pull in our genetic testing data, and in this situation, it's really simple because I created this to have, 8 rows of data. However, let's say, we're working with 10,000 rows and 4,000 rows of data, and we don't want to, go through the process of merging or doing a VLOOKUP or any of the outdated stuff that you typically do whenever you are working with these data sets and trying to get it into a pivot table. So the first thing we're going to do is we're going to set these spreadsheets as tables instead of just working with the spreadsheet range here. This is actually fairly simple. So we're going to go into our screening data set. We're going to format it as a table, select whatever formatting you like, select your data, your data range, and then select that your table has headers if you have them. Go in here. We're going to go ahead and rename this table screening. That will be important later, so just keep that in mind. You would rename the table by going to Table Tools, Design, coming over to Table Name, Screening, and then proceeding from there. We're going to do the same thing with our genetic testing table. So we come over here, we go to the new spreadsheet, which is genetic testing, format the table, create the table, select our date range, select that we have headers. Come in here, we're going to rename this genetic testing. There's a rule here that your table names can't have spaces. You can have underscores or no spaces. In this situation, it's fairly simple. But there's several reasons that you're going to want to switch these over from a standard spreadsheet into a table. So the first is when you're in a table, you can control the formatting of the entire table without having to go through like each row or select the sections that you want to work on. The second is header visibility. This is again something you can do through the view function on a spreadsheet, but as you see, the headers stay with you as you scroll through your data. A third is going to be the ability to filter and slice your data directly from the table, so we can come in and do any sort of adjustments here that we want to, instead of having this static column. The fourth, and potentially the most important, is that you can start creating relationships between these tables. And so part of this next discussion is going to look really similar to about 4 of you who are piloting this this Caboodle and SQL program with us. But there's this idea in relational databases that if you can find identifiers within databases that you're looking to merge, you can connect those and create a relationship between them in order to pull the data together instead of having to manually do it like you would on the spreadsheet. So now what we're going to do is actually set up the relationship between our screening and our genetic testing table. So we'll start at our ribbon up here. And we are going to go over to data at the top ribbon. We're going to go to manage data model. And what we'll see right now is this is actually blank. This means there's no existing data model within this spreadsheet. So for now, we're going to close this out. We'll come back to it in just a minute. So what we need to do is create this relationship. So you go to the relationships button on the data ribbon. And right now, again, we have nothing to manage, so we're going to create a new one. So here, we are going to start with the non-primary table. So here, we'd like to start with genetic testing. And we know from our 2 tables that we have ID available in both of them. And so we would consider on the non-standard table, non-primary table, the key that connects you to your primary table is going to be called a foreign key. So we know ID is going to relate back to the same ID, the same patients on our screening table. So our related table is going to be screening with a primary key of ID. So now we're telling the system we're going to create a relationship between our screening table and our genetic testing table. We're going to merge that data based on the ID column. Click OK. And now we can see that that's an active relationship between these 2 tables. Now let's go back to our managed data model. We see that we have both the genetic testing table and the screening table available in our model. If we come up here to diagram view, we can look at something called a relationship or a join table. And what this shows us is where these 2 tables are connected. So if we hover over this, we can see that we have a relationship here between ID and genetic testing. And these numbers here denote the relationship is going to be 1. The asterisk means many. So theoretically, we could have a patient, let's say somebody who tests positive for some sort of genetic variant for FH, and they're a compound heterozygote. So in the screening data table, they have a single ID, and they'd have a single value for their LDL cholesterol. But if they have compound heterozygosity for the LDL receptor or ApoB, they could have multiple IDs listed in the genetic testing table. Each one would be listed out per genetic variant that's found. And so that's the idea of a one-to-many relationship. This will also, again, look familiar to the people doing the Caboodle class with me, because this idea of a join table will come up as we get more into getting familiar with the relational databases behind Epic. So we're going to exit out of that. And let's see where we are. So we created the relationship. Next thing we're going to do is create our new pivot table that includes all of this data together. So we're going to go to a new sheet this time because it's a little bit simpler when you have a data model that exists already to just create a new sheet when you want to go into your pivot table. So we're going to go back over to our insert ribbon. We're going to click pivot table while we're in this blank sheet. And what we'll see is that instead of a table or date range, now we're going to default to use this workbook's data model. And so we're going to go ahead and select that. We're going to go into the existing worksheet, and we're going to see a new pivot table pop up. Now over here on the right, we actually have the tables listed. We can open these up and see what variables that we have listed available to us. So now we're going to go ahead and create our new pivot table. So we're going to do that by going into, let's say we want to look at like sex versus variance identified. So our rows here, we're going to go into our screening data set. We're going to identify sex as our rows. We have male and female. And then our columns are going to be in our genetic testing table. I'm going to go over to variant, and we're going to identify, we have some blanks, obviously. ApoB, LDL receptor, PCSK9 are going to be our typical variants that we can identify. And then because we know those variants exist within that variant column, we're going to use those to count the variants that are present. And so now what we're looking at is a new pivot table that's combining, again, this is simple, but it's combining the multiple tables with data that don't exist on either, all the data does not exist on either table. And with that, that is all I have. So thank you for your time. And I'm going to figure out how to leave this up to see everybody in case there are questions.
Good job, Luke. I was going to say, I never knew that you could do the timeline thing. That was really cool.
Yeah, it's helpful in obviously certain situations. I mean, it's not always that great if you're working with like baseline data, but for this
Yeah.
especially, when you have some sort of time frame or volume that you're needing to assess at a rate, it's definitely helpful.
Mhm.
Can you do median with pivot tables? I've tried to do it before and I've struggled.
You know, I feel like I figured out a way to do that previously. Let me get back to you. So not based off the typical like options available, but I feel like I found something one time and I did that because I had a data set with some really extreme values that for some reason, we decided to not exclude. I'll get back to you with the solution. I can send that out to everybody.
Okay.
But I'm like 95% sure I found something for that.
Okay. Yeah, because I mean, especially my COVID data, that's one of the things that a lot of the values are really extreme.
Yeah.
And I ran into issues with that when I was just trying to summarize it. But when I was searching, I couldn't find anything, so I had to just do it manually or pull it into SAS.
Yeah, I will I'll look into it and get back to you.
Thanks.